Hey everyone, welcome to Parallel Lines Unit 2, Part 2. So your quiz was on Part 1, and for Part 1, we talked about if lines are parallel, then the corresponding angles are congruent, the alternate interior angles are congruent, alternate exterior angles are congruent. In this section, what we're going to do is we're going to kind of flip those. So we're saying here, if the corresponding angles are congruent, then the lines are parallel. So that means if I know angle 1 is congruent to angle 5, I can decide that AB is parallel to CD. So we're doing it backwards of what we did in the last unit. So our corresponding angles are still all the same. So in this case, they are 1 and 5, 2 and 6, 3 and 7, and 4 and 8. Those are all my corresponding angles. It also says that if my alternate interior angles, which would be angle 3 is congruent to angle 6, implies the lines are parallel. Or angle 4 is congruent to angle 5. Those are also alternate interior angles. And again, the angles are the same as what we studied before. It's just that now we're doing it backwards. So the alternate exterior would be 1 is congruent to 8, or 2 is congruent to 7. Both those imply that AB is parallel to CD. If the interior angles on the same side of the transversal are supplementary, then the lines are parallel. So this is saying that if the measure of angle 3 plus the measure of angle 5 equals 180, then AB is parallel to CD. So again, it's all the same theorems, it's just doing them backwards. So the measure of angle 4 plus the measure of angle 6 equals 180. Then AB is parallel to CD. If the exterior angles on the same side of the transversal are supplementary, so this would be the measure of angle 1 plus the measure of angle 7 equals 180. That would mean AB is parallel to CD. Or the measure of angle 2 plus the measure of angle 8 equals 180 would mean that AB is parallel to CD. In a plane, if two lines are perpendicular to the same line, then those are parallel. So that's a new theorem, but that's saying that if I have this line AB, where CD is perpendicular to it, and DE or EF is also perpendicular. So it's saying then I know that CD is parallel to EF. So, some examples. Given the following information, determine which lines, if any, are parallel. State the theorem. So here we're saying 3 and 9 are congruent. So if 3 and 9 are congruent, then this line is our transversal. And then those are on P and Q. So that would mean P is parallel to Q. And that's because alternate interior angles are congruent, implies parallel. So now if we look at 2 and 7, 2 and 7 are up here. So this line's my transversal, which also means P is parallel to Q, but these are corresponding angles. Congruent implies parallel. And then our last example is that 2 and 6 add to be 180. So 2 and 6 are also on that pink transversal. So those are same side interior angles, are supplementary because that's what adding to 180 means, implies parallel. And that would also be P is parallel to Q. So now we're going to find the value which makes these lines parallel. So if I want A is parallel to T, that would mean that 93 and x plus 44 have to be 180 because those would be same side exterior. So name the type of angle pair. So I have same side exterior. So that means 93 plus x plus 44 has to equal 180. So I solve that equation by first adding 93 and 44. And I get x plus 137 equals 180. I subtract 137 and x equals 43. So now I want you to pause and try to do number 3 on your own and then come back and check your answer. So these two angles, if I'm trying to prove A and T are parallel, would be same side interior. So if they're same side interior angles, that means they are supplementary. So that would mean x plus 20 plus x minus 20 equals 180. So that's 2x equals 180. So x equals 90. If you have any questions on any of these, please bring them to class. Please remember you are responsible for taking notes in your note packet. I will be collecting the note packet again before the next quiz.